Hi there. In this video, we'll learn some fancy counting techniques. How many squares are there in this picture? Well, let's find out. 1, 2, 3, 4. Oh my gosh, I give up. There's just too many. I'm already looking for a faster, more efficient technique to count these squares. And I think the way to do it is to look for not individual squares, but groups of squares. So let me change this question right here. How many groups do you see? Well, I was thinking about this the other day, and I realized that there are two groups of squares. And here they are. One, two groups. And then I realized that each of those groups contains two groups. 1, 2. And that each of those groups contains two groups, and that each of those groups contains two groups, and that each of those groups contains two groups, and that each of those groups contains two groups, and that each of those groups contains two squares. Did you follow all that? Here it is again. That was two groups of 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 two. Voila! So that's how many squares there are. Oh my gosh, that's kind of a mouthful. Why don't we invent a new symbol to represent all these groups? And let's call it power notation. 2 to the 7th power will represent two groups of 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 two. So much simpler. In fact, this notation is so great, we should try it out right away on a different situation, like this one. How many green squares? Well, there are 5 groups of 5, each of which contains 5 groups of 5. 5 groups of 5 groups of 5 groups of 5 makes 5 to the 4th power. Just lovely. Are you feeling brave? Try out your power notation skills on this drawing. Try to represent the number of yellow squares using a power in as many ways as you can. In fact, there are several ways to do it, so you'd better get started. Thanks for watching.